3, 4. Hello, and welcome to a tutorial for making a DOTA2 preview shader, GLSL preview shader in Blender of sorts. Well, preview shader of sorts in Blender. As you can see here, I've got, this is Blender here on the left side of the screen doing the real-time GLSL rendering, and this is the DOTA2 model viewer for the same item. And they look pretty close, and so I've been tinkering with this and trying to get it to work, and I think I've got it good enough to make this tutorial, and if anybody wants to can one-up me on this, that's fine with me. But yeah, I'm going to be covering setting up this whole shader for doing this whole preview shader, and then a little bit of compositing some of those the textures into actually making the texture masks. And I wanted to do it so that that composite could go entirely in Blender, but the Blender of versions higher than 2.65, the compositor does bad stuff when you add with the alpha channel, if the alpha channel's got grayscale values in it. So it'll be a combination of Blender and GIMP for creating the shader masks. But it'll be faster than my old tutorial for GIMP of starting with a base texture and then decomposing that and then doing stuff in those individual channels and then recomposing it. And you'll get some fun, like, real-time preview stuff of what's going on, what you're doing with it. So see, I can go into here and go to my specular intensity mask. Boom. And just turn specularity completely off. So yeah, that's the gist of this is being able to do all the texture masks and paint them directly on the object and get real-time feedback that just about matches what you'll get once you import it into DOTA2. And it's not perfect. I'm not claiming it's perfect, and there's some weirdness. Well, I'll get into it when I get to those things. So, where do we begin? Alright, so we are going to begin with a brand new Blender file. And I'm going to start with... Okay, so I'm going to start by... I'm just going to create a default cube. I'm going to demonstrate all this on the cube first, and then I'll import my other things to demonstrate the baking and some cycles of baking and stuff like that. But for the actual shader setup, I'm going to start here. So we need between like 8 to 10 textures based on, because we need a texture, we need a color map, we need a normal map, we need one texture each for all of these. But I'm going to skip the detail map and the diffuse Fresnel mask because my preview shader does not actually use them. I don't know how to do the diffuse Fresnel mask, and detail map mask would work. Essentially, you could basically use a duplicate of the self-illumination or whatever and make changes to that to get that to work. Or use the same process. I'll tell you when I get there. So, start with images. Okay. So we want new, we're going to name all these correctly. 2048 for the texture size, because that seems to be... I've had issues with the DOTA2 importer handling textures smaller than that, and bigger than that you're going to run into some other problems. So color map 2048 by 2048. Okie dokie. Then another new image. This is the normal map. Also 2048 by... Important thing with the normal map, though, you want your RGB values to be 0.5, 0.5, and 1. because that's the flat normal map. Because if your normal map is black, when you apply it to the shader, it's gonna cause some weird shit to happen. Alright. Here, bloop while I consult my notes. Okay. Metalness, and that one can go back to being black. Self-illumination. Specular intensity. Rim lights. Tint spec, and that's the specular tint thing. And spec exponent. So now we've got all of our images. Now that we have all our images, what do we do with them? Well, what we want to do is we want to create a... This is all in Blender internal. Well, first of all, turn on... a lot of people use screenshot keys. I do not use screencast keys, so I'm going to assume that you know what buttons you have to push to do things. So turn on GLSL, shading in there, switch hue to textured. Now let's just throw a sun lamp in here. Front. There we go, and then let's actually unwrap the cube, and we're going to do edge, mark seam, and unwrap. There we go. Where are you? Pack Islands isn't necessarily what I want, but I do want constraint image bands. There. Fine, whatever, that's fine. Okay. So then we do a new material. We're going to call this material DOTA2 preview. And then we go to the node editor. The node editor actually does work for Blender internal. It's not as cool as Cycles, but you know, it gets the job done. So then we got just our new material here, material node. Create a new material, and this is going to be our color map material here, and that is diffuse only. Okay, and then we go into textures panel over here, create a new texture. This is going to be normal. Nope, this is normal. We go image sampling, normal map, geometry normal. Mixes the blend, that's fine. Then we want to do other material, That one's color. And that one, of course, uses the color map. Then another material. This one's metalness. And that one uses the metalness map. But then, what we do with these, we do input, texture, color, input, texture, metalness, input, geometry. This is very important. Never ever forget this, because Blender Internal is a real stickler about you manually plugging in the UVs for the geometry. And then we got so we can plug that in to the color here, and then just a quick show that it works. If it worked. Why are you not working? Oh, that's duh. Okay, for when you go into the texture painting, you have to use image. You can't use the material slots when using nodes. And it would be nice if, okay, it's clearly adding it, but it's not. Intensity 1. Are you not using? No, you're using the UV. So it's painting there. Oh, wait, is this? Ah, that might be it. I'm dumb. Okay. I know what I messed up. Okay. Normal. No, it's using UV. Oh. Duh. Once you add these nodes, I'm real dumb. Then remove these from the list. Otherwise, you will look like a dumb person, like I just did. Okay. So yeah, I messed that up less than I thought I did. Okay, that's all still good. Okie doke. Yeah, because it evaluates the textures in the list going down, but since we don't actually care about the ones on the list other than the normal map, because we want these. Okay, so then metalness, because the way that they describe in the DOTA2 guide, the shader masks guide, what metalness does is it reduces and darkens the color and rim light, and then you basically make up for that with your speculars and stuff to make up for it. So, metalness, you need to invert the color for the metalness, and then that's going to be multiplying the RGB, the base color map, the factor of 1. And then, so if I go into metalness and go white, then you see that multiplies. See, it inverts the metalness mask, so it turns white into black, and then black multiplies by the values in there and turns it into 0. So that's not exactly what we want. We do want to have it be slightly better than. We don't want it to go all the way down to 0. So we throw in a color ramp node here, and at black we put that to like, not you, HSV, put its value to like 0.4 for gray, so then it'll reduce it, but it won't wipe it out when you're doing the colors, the metalness. And that Let me consult my notes, make sure I'm not forgetting something here. Specular. Nope. Yeah, that's good. Okay, that is the diffuse node, or the diffuse material. So we can take all these nodes and group them, just so that our nodes aren't a giant stupid mess. Call that the color map. So then we get into specular. Oh, whoops, I shouldn't have grouped this yet. Oh well. Alt-G. Want to duplicate that one. And now I can group these. There we go. Because I want this one, since this one already has the normal map applied, and I don't have to duplicate that. I have to deal with doing that again. So we turn that one specular on, diffuse off for that. Then we also do specular intensity to 0 and hardness up to around 200. You can play with this value. 200 is what I've found that I like for that. So then we have so then we need the color map again. And we also need a new texture. The texture right in here. And this one is going to be, what is it? Color. This is the tint spec. Oops. No. Or color. Oh, tint spec. Son of a. Why are you being dumb? There, okay. That was stupid. Alright. Your color again. Oh, that might have made... Yeah, that messed me up in here, didn't it? So don't do it that way. Don't make textures that way. I thought it would be easier. It was not easier at all. Okay. So we have tint specular and color. And again, we need the geometry node. UVs. And this gets us another mix RGB. And we want color in the bottom slot here, and then color for the tint spec into the factor here. And then this all the way at white. And that's left as a mix, and that color goes into specular here. So now if we go into color map, and let's actually put some real colors in here. Okay. And then it does nothing right now because specular is not actually turned on. So we have to turn on specular. So we'll create a new texture. This is the specular intensity. And that uses spec intensity. But that does not affect color, that affects intensity. And that mix there is an add and an RGB to intensity. So that way, so then what we can do is we can then go into spec intensity, just white, and then it's just fill this all completely with white, and that should make it specular. Totally intense if this was working. Specular intensity, spec intensity, VMAP, GLSL, what is going on now? Why is this not? Oh, is this no? Because hardness should be. Where are my specular highlights? Should be working. Specular reviews. It shows it right. Oh, duh. I'm dumb. Okay. I keep making myself look like a total stupid person. Okay. So we have to mix RGB on this, and there's an add that to that with a factor of 1. Now we should have specular highlights somewhere. There we go. There it is. Okay. I always forget to do these, doing things in the wrong order to get my previews. And then there's one more thing in here that we've got to do. Have another new one, and this one is the specular hardness, or the specular, this is the specular exponent. And this one uses spec exponent. Again, not using color. And that uses the hardness. And that is a multiply. RGB to intensity. Bang. And since that is 0 hardness, it is going, makes it all the way to like the least hard specular ever imaginable. So we need, but we don't want it to be that crazy. So we want to reduce the influence of that to 0.925. And that makes the specular really soft, but not like stupid crazy soft. And then we can go in and go into the spec exponent texture. Texture raw. I'm gonna do something real quick. This texture here. Why aren't you letting me rename you? Brush. And then we can go into the texture panel and go to the brush textures. And then this is a. Just go with a marble texture. And then bring that size up. See, and then you can see that the way that affected the specular. So we've got long specular highlights where it's 0, but then it's really hard in the higher value places. And that is, oh, nope, never mind, I did do that already. Oh, yeah, and to show the tint specular, let's go image tint specular. Let's just go with a regular draw brush here. And you can see that the color of the specular now matches the underlying color. Which is important for the metalness, because you can see that the metalness actually brings the actual visible color down, but then the specular makes it look back full again. And that is the specular map. And we can do that, and then we can group those out. And that is specularity. Which is easy peasy. Okay, so next up, specularity. Self-illumination. So we need another material. Let's call this one self-illumination. Turn specular off on that. Now the other thing here, so then we just turn emit up to 2 right here. Now, I'm sure if you're familiar with Blender, I'm sure you're thinking, well, okay, before I get to telling you why you're wrong, let me actually show you the thing that you're going to say that I am wrong. Show you the thing that you're going to say that I am wrong about. So we have our emission node here, and then that one, that texture is color. And then create another mix RGB node. And that one plugs into there. That color goes to there, color goes to there. And then we do input, well, actually, I have to do an actual new texture node for this. Create the texture this way. Self-illum. And that one uses the self-illum texture. And then shift add. Input texture. No, don't do that. Does not have that at all. Okay. That one is self-illum, and then drop that from the list there. And then color for this goes into the mix factor there. Bang. And then obviously the UV geometry input there. Okay. So here's the thing that you're wrong about, because I'm sure you're saying, like, well, why don't I just use in the material, why don't I use the self-illumination texture as, and have set that up as the, just the emit influence there. And it's like, yes, I could do that, but the problem with that is then the emission would be maxed out at about 1. I mean, I'd have to do an add or something. Well, okay, well, two things. It would either be that the emission would always be on at, I'd have to have the emission, I have to start the emission at 0, and then it would be an add emission, and so it would only go as high as 1, which we don't want. We want the emission to be, we want the self-illumination to be really, really bright. So that has to be 2. But then, if we have that as 2, then this doesn't really, this becomes like a multiply or something, and it's not, I don't know, it's just not as clean, I feel, as just using that as the mix factor for adding a self-illumination to the thing. So, I mean, I can go into here now, and I can go, of course, do I have any? I don't know if I've drawn on any of these dark faces. slots? No. Okay, go into self-elimination and then just... that's a face, has nothing on it, but then do color green. Why does that? What are you doing? There we go. That was weird. I don't know why that needed to be refreshed. But yeah, see, now you can see just how bright that is comparatively. And then I can go into here and then do self-illumination. There, and then if I can rotate the sun around. That's, yeah, so you get the anyway, so yeah, so that works, and I like the way that works better than I otherwise would. See, now unfortunately this whole mess here doesn't really turn into a group node particularly well, so we'll just leave that hanging out. These geometry nodes don't collapse very small either. So that's self-illumination. So after self-illumination, we go to rim light. Okay, rim light it doesn't work very well. I'm gonna be straight up front and say that my attempts to approximate the rim light is not very good at all. So if anybody else can come up with some better way to do this, I would be, let me know in the comments or something, because I can't figure it out, and I've been messing with it a lot. So again, this is a specular only material, but this one, instead of doing a Cooktor specular, we do Fong, which is a bit softer. Do the intensity all the way up, and the hardness all the way down. So this is just like a really big, really soft sort of specular. This one also needs the normal map. And then, okay, we need the rim light texture. Just rim light. Put texture. Rim light. And then just drop that from the list again. And then we also need, I'm going to move these up here for reasons that will become apparent. Let's plug that UV into, plug the UV into there. And we also need metalness. Is that metalness? Yes, that's metalness. And that is because that was as mentioned in the thing, the metalness mask it reduces the rim light as well. So then we do another mix RGB. Where are you? That's when color 2 is black, color 1 is the rim light texture, and the factor is the metalness texture. So that way, where metalness is white, no matter what rim light is, rim light will be black, which is... So that means that when something is metal, that doesn't have a rim light effect applied to it. So then we do that. Then we do another mix RGB. And this one knows color 1 is that one, because this is the mix of all of our other things. And color 2 is the rim light material, which is just a big crazy specular. And then the factor is U. Now, it just suddenly occurs to me that I should probably have also, as part of the rim light, I should duplicate the specular materials the setup in the specular material, this setup in the specular material with the color. Specs RGB, spec, input, texture, color. What was that again? Yeah, okay. That was white. Add input, texture, tint specular, color, factor, geometry, UV. Okay. So yeah, and then that I can group again. That's rim light. Rim light. Okay. And that is pretty much, that's the whole thing. I mean, rim light, again, the rim light is really, really hard to make work right. It both takes some pretty specific lighting to make it appear properly, but I mean it sort of works. You kind of get. I'll actually show it to you instead of talking about it. So you know the normal already. Okay. So I will add to the cube Hello. Okay, I'm just cutting in here because while I was editing that all together, I realized that the reason that my rim light material was not working right there was because I had forgotten to plug the mix of the rim light material and the other materials into the shader output. So this is what my node setup looks like while I'm waffling around just there right before I cut in just now. And that is, of course, this is what the thing looks like, more or less. This is the object. And then, so, if you set that mix to a divide, and then actually plug it into the output, and you can see that, the preview there changes. And then you can even see that's what the object looks like, and then once you plug that in, then you get that little the rim light effect sort of pops up right there. It's not a super strong rim light effect, but it does kind of work, and it definitely works better than not having it plugged in at all. So I'm now going to return you to the rest of my tutorial. Okay, so now I'm going to, enough of the setting up the shader stuff, I'm actually going to go into talking about baking out the masks and compositing. So for that, I'm going to append a couple of lamps. So you and you. I'm going to append these into the thing. Okay, you will now get. I'm going to switch this to the DOTA2 preview material, which, as you can see, so you can sort of, this kind of gives you a better sense, so you can see the way that the texture paint mode, slots, rim light, okay. Maybe not. Yeah, no, it doesn't. Okay, never mind. It didn't really translate. Okay. So I'm gonna just go one at a time, just blank out all these texture maps again. Okay. Actually, I'm going to go back to color, and I'm going to fill that with 50% gray, just so that we can see it. Alright, so there we go. So now, what I'm going to do is open up the node editor again. You can see this whole thing here. I'm going to group all these nodes together because this is our, oop, hang on. There, this is the Blender internal material. That does all these things. Okay, and then we are going to swap over to cycles rendering. And there's going to be a new material. Oops, no. Don't need a new material. We can still stick with DOTA2 preview. Let me just do output, material output. Actually, I don't even know if I need to do that. I just have to do texture, image texture, normal. Okay, so we're gonna unhide this. This is I made this out of a sculpt. I'm gonna hide that cube because it's dumb. Now, can you not hide a cube on? It's weird. Cube. hide. There we go. Okay. So yeah, I did sort of modeled this helmet, and then I was sculpting on it, and then I realized that my topology was terrible for sculpting on that, and then I retopologized it and made it much more detailed, and then I retopologized that into that for use in Dota 2. So this one, so the retopo, I can select you, select low poly, cycles, we can do cycles baking. We can bake out a normal, selected alpha cage, 1.25. And hopefully this will work. Go to normal. And bake. Damn it. There we go. Okay. Oh shit. It's gonna crash. Okay, whew. Okay, I don't know why it didn't crash. Should have crashed. Check mode. I guess I managed to stop it in time. Add a camera. There has to be a camera in the scene for cycles baking to work. I totally forgot about that. Alright. Bake. Let's try that again. That 16 pixel margin might be too much too. But we'll see if it even bakes. There we go. Okay, there we go. Normal map. So now if I hide, oops, that one, hide that one, switch you back to Blender render, and you can see the normal map is applied and working. And that is, I think, good enough for government work on the normal map front. So I'm gonna do... Yeah, I'm not gonna go through the process of baking out all the individual... Because I set up some... render. There are some... Yeah, there's some vertex color maps on this that I used. So I got like actual color, and then I've got a sort of a dirty vertex colors, and then that can be, I forget what this was. But yeah, actually baking them out is kind of annoying. So I'm going to skip that altogether, and I'm just going to paint some dumb stuff onto this. Alright, good enough. Okay. I think that's enough different maps that I can sort of throw out go into compositing this thing and compositing them and show you how the compositing goes together. So we go to compositor, nodes, use nodes, and then backdrop. Drop that, and that as well. So now we go back to the guide. So mask 2 is specular intensity, rim light intensity, tint specular by base color, and specular exponent. So we want output viewer, converter, combine RGBA, image to image. So what we're doing mask 2, so specular intensity, just input, image. There are all these duplicate spec intensity. This is the one that I just threw together. Plug that into red. You can see in the backdrop that's what the red channel looks like. If I go here and show the red channel. Input image, intensity, rim light intensity. Now that's an issue because, as it says in the guide, if it's a full black or full white image, will not like it. So if we just throw a splash of white up into the corner for rim light, image, that rim light, then that'll be good enough. And you see it pops up in the green right there. And then blue is the tint specular by base color. Add input, image, tint spec. Plug that into blue. And that's, yeah, gives us all that stuff. So then we have red channel, green channel, blue channel, all channels. Now this is the thing, says alpha is specular exponent, right? Okay, so it's fine. Close these guys up. Look at specular exponent. I've got there are some gray values in there. I mean, it's not as gray as it might otherwise be. In fact, you know, I can just let's get some stuff, some grays in here, just to different gray values, because what happens is if you plug something into alpha in the compositor, now if we look at red is not what it was before. So that's what red should be, because the compositor pre-multiplies, the Blender compositor pre-multiplies, let's just go all the way to here and then fit here. Okay, the Blender compositor pre-multiplies all the other channels by the alpha channel, and that destroys the data that you want in the alpha channel. So what you have to do is you have to just do the RGB combine as one file. So we can switch to use the viewer node. So I can save that image out. Let's put this into Let's call it test TGA again. Save that as a TGA. Save as image. And then save out the spec exponent as a different image. And you can actually save that as, keep that as a ping if you want. And then you gotta go to GIMP. And I'm sorry, but I really wanted to be able to do all the whole thing in Blender without leaving Blender, but Blender 2.65 doesn't pre-multiply the alpha, but if you're going to swap between blenders, then you have to save out all the images anyway. But this is actually not too bad as far as speed goes. So you do test TGA, and then you can do add layer mask, doesn't really matter. And then, what did I save you as? Spec X ping, cut, paste. Did that not work? No, fine. Alright, cut, delete, paste, and that pastes it into the mask. And then you just have to do apply layer mask there, and then I'll show you if you do the decompose RGBA, all of your channels are there and are what you want them to be. So I'll save that. So you do that, and then you just resave this as your mask 2. Save, and you're good to go. You've got a perfectly functional mask that DOTA2 won't choke on when you try to import your thing. And that's basically it. That ended up being a somewhat longer tutorial than I had initially planned. But yeah, I mean, you do all that. I mean, that's process. Let's go back to the 3D view. And this is obviously not super duper great. Backface going back on. It's not perfect, but I feel the shader setup. That shader setup gives you a real sense of what you're going to get when you put it into DOTA2, and that whole, I know I just kind of flew through the compositing at the end there, but that composite is a faster way of actually generating the masks than you would than doing it completely manually in GIMP. And I mean, the ability to just paint the masks directly onto the object and see what you're trying to make, and see more or less what you're going to get when you put it in game, and is, I think, just super duper useful. I hope you agree, and I think I'm going to stop this tutorial here because it's been a kind of a long one. So thank you for watching. Check out other stuff on my channel. It's kind of eccentric. It's an eclectic mix of different things. And have a nice night, and happy blending, and happy DOTA2 workshopping, or whatever.